Here's the derivative of the hyperbolic tangent function, tang x, I guess it's pronounced. So d dx of tang x equals hyperbolic secant squared of x. I'm not sure how that's, I guess sech, I don't know. Anyway, derivative of hyperbolic tangent equals the hyperbolic secant squared. So let's go ahead and see why that's true. So d dx of tang of x. So hyperbolic tangent of x is defined to be the hyperbolic sine of x divided by the hyperbolic cosine of x, which is good because that means it's analogous to the circular trig functions sine and cosine and tangent. So that's really good. Now we could proceed like this, or we could do it in terms of the exponentials, e to the x and e to the negative x. So we could do it like this. Sinh x divided by cosh x. If you go back to the definitions in terms of e to the x and all that stuff, this would be e to the x minus e to the negative x over e to the x plus e to the negative x. It would simplify to that. And that's definitely doable, you know, and it wouldn't really be too bad. But because we already talked about the derivatives of these, sinh and cosh, let's just go ahead and do it like that. It'll be a little bit quicker this way, a little bit less messy algebraically. So we'll just do it like that. Okay. So if you are so inclined to do, you could do the quotient rule on this. It'll be a little more messy, but still mostly straightforward. So anyway, let's just keep going with this. Quotient rule says the derivative of this is going to be bottom. Okay, bottom times the derivative of the top. The top is sinh of x, so the derivative of the top is just cosh of x. And then minus the top, which is sinh of x, times the derivative of the bottom. The bottom is cosh of x, and we saw in the last video that the derivative of cosh is just sinh of x, all divided by the bottom squared. Okay? So that's a quotient rule there. So again, bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. All right, so now what do we have here? Cosh squared of x minus sinh squared of x. And then all that's still divided by cosh squared of x. Okay, so there's an identity for these hyperbolic trig functions that actually says cosh squared of x minus sinh squared of x is equal to 1. So remember for cosines and sines, we know that cosine squared of x plus sine squared of x equals 1, right? But for hyperbolic trig functions, it's a little bit different. For hyperbolic trig functions, the identity is cosh squared of x minus sinh squared of x equals 1. All right, and that's kind of a topic for a different video for a trig unit, I guess. But anyway, you could see this if you go back to the definitions in terms of e. So if you have e to the x plus e to the negative x all over 2, okay, that's cosh x, and then we square it, and then minus sinh squared of x, that's going to be e to the x minus e to the negative x all over 2 squared. So this is cosh of x and then squared, this is sinh of x and then squared. So if you were to expand all this out, simplify, etc., etc., you're going to get 1. Okay, so that's that. So if we come back down here, this is going to be 1 over cosh squared of x, which just by definition is hyperbolic secant squared of x. This is just a definition here. So hyperbolic secant of x is 1 over hyperbolic cosine of x. So hyperbolic secant squared is going to be 1 over hyperbolic cosine squared. And that's the proof that the derivative of hyperbolic tangent is equal to the hyperbolic secant squared.